And we now have another talk by Christoph Guttandin about polyfills for AudioWorklet. So all the different polyfills we can use in browsers that still don't support AudioWorklet, situation that hopefully will resolve soon.
No, I don't have one. Testing. Test 1, 2. I want to compare apples with oranges, or in our case, I want to compare AudioWorklet polyfills. And when that works, I can switch to the next slide. That's me. I'm Christoph Guttandin, and most of you know me already, probably. I have a little company called Media Codings, and I build multimedia applications for the web, which is why I'm so interested in the Web Audio API. And I'm usually named Chris Guttandin, so if you want to reach out to me, you can ping me on Twitter, that's my Twitter handle, or you can find me in our Slack channel, or almost anywhere else on the internet. And you probably all know that we have a lot of audio nodes that are provided by the Web Audio API, and they're tiny little pieces which we can use to build our applications. And we have a lot of them, and we can do a lot of things with them, but there will always be that one audio node that you really wish to have, but it's not there. So we need a mechanism to build custom audio nodes, and up until recently, the script processor node was the thing we could use to do that. And up on the screen, you see a diagram that was my attempt to explain the script processor node. So you see two threads, like the audio thread and the main thread. And the script processor node works by you specifying the buffer size at the beginning. You have to explicitly tell it what kind of buffer you need, if it's only 256 samples, or it can be up to 60,384 samples. And depending on that, most browsers do double buffering, so they double the buffer on the audio thread, and then whenever they think it's time for more data, they fire an asynchronous event on the main thread, which is called the audio process event, and then you have to handle that event and have to fill the buffer. And the problem is, the problems are the arrows, which I inserted in the diagram, and they should symbolize asynchronous calls. So when the audio thread calls the main thread, it fires an event, and that event is a regular JavaScript DOM event. So it competes with all the other events from mouse interactions and the user is resizing the page and request animation frame and set timeout. And they all run in a queue, and they basically get executed one by one. And if you have a click event which takes 100 milliseconds, then you certainly have a problem because the audio process event can't be handled quick enough anymore. And then once that is done, the data has to go back to the audio thread again. So that's the reason why it's problematic, because we have these asynchronous calls in the rendering pipeline. And that's also the reason why it's deprecated. But we do have the AudioWorklet now, which also lives on both threads. It lives on the audio thread and on the main thread, but it doesn't have any asynchronous communication anymore. It still has it, but not for the rendering. So the rendering is completely handled in the audio thread on the right side. And it's done by the AudioWorklet processor, which is only concerned about rendering 128 samples, each render quantum. So there will be no artificial delay because it's running in the same loop as the audio API itself. And if you want to communicate with it, you can either specify an audio param, like with every other audio node, or you can send custom messages over the message board. And that happens asynchronously, but it's not a problem because it doesn't affect the rendering directly. And the AudioWorklet is only available in Chrome so far. It's coming to Firefox as well, but at least for the foreseeable future, there will be no AudioWorklet in Safari. And so we have to do something like this. We have to check for the AudioWorklet if it's available, if we want to use it, and then we use it. And if we can't use it, we have to come up with a fallback, which is most likely the script processor node for now. And this is unfortunate because in that case, we have to maintain two different parts of our code, which do actually the same, but are different. And that's usually where things get out of sync and bugs get introduced very easily. So it would be much nicer if we have something magic that we can just import and then pretend the audio worklet is there. So that's what the polyfill is made for. It can, of course, not re-implement the audio worklet because that has to be done by the browser vendor, but it can provide us with the same API by faking it under the hood. And that faking needs to be done with something we have already, and this is just a random list of APIs that the browser provides, so you don't have to read that. It's just to show you the principles of building a polyfill, that you just take whatever is there and then you combine those, and these are, for example, the ones which people use to build polyfill the web audio API, the audio worklet. You just try to find things which are already available and then build something which is not there with them. And the first polyfill that I'm aware of was built by Ari Klemola for the Web Audio Modules project, which is the one Michel presented earlier. And he achieved that by using a script processor node, and additionally, he used also a web worker, which is symbolized by the worker thread. And the web worker is doing all the processing. So the audio worklet processor is running in the web worker, and that has a big advantage because it's nicely isolated. It has its own scope and its own runtime, its own thread, so it's running in parallel. But it also has the problem that we have two more asynchronous calls back and forth. So in order to avoid that, I built another polyfill for my library, which is called Standardized Audio Context. That is a library which polyfills the whole Web Audio API, and so I had to have a polyfill for the worklet as well. So my attempt looks like this. I removed the worker and instead evaluate everything on the main thread, which can be risky if you run third-party code. If you have an audio worklet which you just downloaded from somewhere, then this is probably not a good idea to evaluate it alongside your other application code, because as Charlie said yesterday, it's JavaScript and you can do almost everything with it. But if you run your own audio worklet, that's probably fine. But the main problem is that you need an almost idle main thread. So you have to make sure all the other things which you need, like the UI framework and stuff like that, is as minimal as possible to have enough time to run the audio rendering on the main thread. And shortly after I released mine, there was another polyfill released by Jason Miller, and he did that for the Chrome Labs project, and he used an iframe to render the audio worklet processor. And that looks very appealing because it looks like it's a different thread, but in reality, as I found out, that's not the case, because if you have an iframe and a main thread communicating with each other, that's synchronous, and once the one is doing work, the other one has to pause, and the other way around, so that's not much of an advantage. The only thing which this brings us is that we have a different scope. So we can easily break out of the iframe, so it's not a security feature, but it prevents some bug that if you access something on the global scope accidentally, that will not work in the iframe. And while I was researching polyfills for the talk, I found another one, which I thought was very interesting. That's by Peter Salomonsen, and it's for his JavaScriptmusic project. And he doesn't use a script processor node at all. He just has a loop, set timeout loop, and infinite set timeout loop, as described in the famous article, The Tale of Two Clocks by Chris Wilson. And inside of that loop, he just renders the data, and then he schedules audio buffer source nodes. And that avoids the asynchronous calls, but it introduces a delay because you have this look ahead when you have to fill the buffer. So it ends up being almost the same. So I tried to categorize all those polyfills, and the first attempt I made was running the web platform tests, which is a suite of tests that the browser vendors write themselves to compare different API implementations. And there is, of course, also a test for the audio worklet. And it scores 100% in Chrome, so all the tests pass. And it fails completely in Firefox, which is expected because they haven't enabled the audio worklet implementation so far. But what already looks a bit suspicious is that they have almost 50% partially succeeding tests. And when I ran it with the polyfills, the result was almost random. And as I found out, the tests rely on other APIs, which are not available in the browsers that I use. So the result is not really valuable for us. The web platform test is actually a very good initiative, and I very much like it, but for that use case, it's not usable. So I have a lot of tests as well for my standardized audio context, because I'm very picky about the exceptions that it throws. It has to conform to the spec as much as possible. But that's also not really feasible to test the other versions with that, because even Chrome only has 70% of the things implemented, which I care about, which is just because me being so paranoid about all the exceptions it throws. So I try to group the polyfills by feature. So if you need, for example, the message channel to have asynchronous communication, you can use every one of them because that seems to be a critical thing and everyone has implemented it. But if you want to use audio params to communicate with the worklet, that seems to be only implemented in standardized audio context. And I'm not sure why that's the case. I think it's just because no one asked for that for the other implementations, but technically it should be possible to implement that. And if you need global variables, so on the AudioWorklet you have this current time and sample rate available. That's only available in the standardized audio context and in the Google Chrome Labs version. And another way to group the polyfills is maybe to look group them by use case. So if you have a real-time application which has to have very low latency, then there might be no other way of doing it than running everything on the main thread with the at least most minimal setup that you can think of, and which is actually the script processor node. And those two polyfills do only slightly wrap it, so that might be the best solutions in that case. But as Paul wrote in one of his latest blog articles, don't use the main thread if you don't have to. So yeah, well, but in that case, I think that's one of the cases where you have to. And if you have still a real-time context, but the usage is more for playback, like if you're playing a song or something and it's not very interactive, you can use the web audio module's polyfill. Again, it introduces the additional delay because it uses the worker thread, but that also makes it more reliable because it doesn't depend so heavily on the main thread. And if you are keen to set the latency hints, you can probably also use standardized audio context because it will then create a script processor node with a much larger buffer, which will allow you to have more hiccups on the main thread without hearing it. And if you want to have an offline audio context, I would probably go for the JavaScriptmusic solution, which is just scheduling whenever you have time. And that's also implemented in standardized audio context. So I have that implementation for the offline audio context. So that might be, it's my recommendation for the offline use. And another thing which you might want to consider if you run third-party code, so if you have something like a DAW and you allow people to upload their audio worklets, then the only option you have is actually the web audio module's polyfill, because that isolates the code in the best way possible. And if you don't do it, then yeah, people might break your applications with worklet. And if you build something which other people should use, then you should, it's the opposite use case, then you should avoid writing something to the global scope or modifying the global scope. And the only two polyfills that don't do it is the web audio modules one and standardized audio context. So depending on your use case, you can probably rule out some of them, and then you end up with one that fits best for your use case. And after talking 20 minutes about performance, I at least want to mention that as long as you don't have a problem, you basically don't have a problem, and don't worry about it. Yeah, and with that, I want to thank you for your attention.
Thank you very much, Christoph. I think we have time for a couple of questions. If you could start setting up in the meantime. Is there any question?
Hi, Christoph. Thank you for your presentation. That's really instructive. We kind of faced all these problems that you mentioned in our implementation of the AudioWorklet for SAMA. Something that we still haven't tried is when we want to implement variable audio buffer size on the AudioWorklet, which I think it entails implementing a double ring buffer.
Oh, yeah.
Have you ever tested any solution that does so, and what were your results?
I heard rumors that Paul wants to present something in his workshop tomorrow, so maybe I shouldn't say anything because he knows it much better than I do.
Do you have another question?
Thanks. It's super interesting to see all these options side by side. I was just curious with standardized audio context, is it easy to just pull the audio worklet out?
No, that's a big trade-off. It's a package which you can only use at once, and you can't get pieces out of it. You either have to use it completely or not at all. So that's the trade-off here.
Any other question? Right, so in this case, I think we can thank Christoph again.
Thank you.